Hi, this is Mr. Adler, and welcome back to Ciencia on Fuego. You know I love all science, but today we're going to talk about a subject that really rocks, the rock cycle. Now, there are three kinds of rock on planet Earth. There's igneous rock, which is made when magma or lava cools down. There's also metamorphic rock, which is made when a pre-existing rock is changed into a new kind of rock by heat and pressure deep inside the Earth. And lastly, there's sedimentary rock, which is made of little pieces of other rocks and even parts of living things like bones all stuck together. But instead of talking more about these different kinds of rocks, let's actually model them using some crayons. So I'm going to get a green crayon and I'll get an orange crayon. Green is my favorite color. But these are no longer crayons. These are actually igneous rocks that I found on planet Earth when magma or lava cooled down. By the way, lava is the stuff you might see shooting out of a volcano. Getting little pieces here. Now, in the real world, what I'm doing is something called weathering. Weathering happens when you break down a rock into smaller pieces. This is what happens when, say, wind blows on a mountaintop and it blows away little parts of a bigger rock. It can happen during winter when water gets into the cracks in rocks and freezes, which can cause a big rock to break and shatter. It can even happen when people like humans walk over rock and break the rock under their feet into smaller and smaller pieces. Over time, this can even make entire mountains get smaller. The Appalachian Mountains just north of Lawrence, Massachusetts, or the White Mountains. All of these are mountains that are slowly getting smaller because of the effect of weathering. Things like running water, ice, and wind slowly but surely breaking pieces of rock off of bigger rocks and getting small pieces that we call sediments. Now, I've got some of my rock here, and since we can weather more than one kind of rock, I'm also going to weather this orange igneous crayon as well. One more time, weathering is what happens when you break a rock into smaller and smaller pieces through the effect of something like ice, wind, and water. Even animals can do this. Things like earthworms burrowing through rock and soil can break rock into small pieces, and trees too. When trees grow through a rock or rocky soil, as their roots burrow down into the ground, they can actually break rock into smaller and smaller pieces. And that's what I'm doing right now with this knife. I'm modeling the process of weathering. But weathering is just the first step if I want to turn an igneous rock into a sedimentary rock. I have my little sediments, but now the sediments need to be moved somewhere new. The next step in making sedimentary rock is erosion. If weathering breaks rock down into little bitty pieces, erosion carries those sediments somewhere new. For example, maybe a rushing river can carry those sediments somewhere new. But today we're going to model wind. So I'm going to really carefully bend down, and I'm going to try, without blowing our sediments all over the lab, trying to blow my sediments into the middle. Okay, there are my orange sediments. Let's get some green sediments. Okay, now, first we weathered the big igneous rocks, making tiny sediments. Then erosion took the sediments into the middle of the foil. The sediments have now been deposited or put down somewhere new. After that, the sediments are compacted and cemented together. So to model that, I'm going to make sure all my sediments are in the middle of the foil. I'll fold my foil up, and I'm going to apply pressure for about 10 seconds. Now, in the real world, this might be layers and layers of sediment under the ocean, pressing together over millions and millions of years. But we only have a few seconds, so I'm hoping that all of the pressure from my fingers will do. Once I remove the foil, we'll see that what I've created has all the little pieces from the orange rock and the green rock. And in fact, I still see some loose sediments, so I'll press down one more time. As those sediments are pressed together under the weight of all of the other sediments that were deposited on top, eventually, after millions of years, I've got a sedimentary rock made of all of the little pieces of other sediments, all the pieces of other rocks that have been stuck together. Now, that sedimentary rock, though, that's not the end of the rock cycle. That sedimentary rock might end up buried deep under the earth. So, to model that, we'll add pressure again. But first, metamorphic rock also takes a tremendous amount of heat. So what I've got here is some very hot water. This hot water is modeling the heat that I might find deep under the Earth's surface. So I'm going to take my sedimentary rock and I'm going to make myself a little bit of a boat. I'm going to put the sides up nice and high so that I don't get any water in my rock. And then I'm going to put it inside the Earth. Well, inside my hot water, which is modeling the heat from the Earth. I'm going to count to 10. Now, my rock didn't get completely melted. I can actually still see some of the sediments. But it's definitely getting a little melty from all that heat inside the Earth's core. One more time, let me apply a little bit of pressure. I've now made a new kind of rock. You can see that I still have both colors, but I no longer have all of those big pieces, those sediments that I had before. What I've got now is a metamorphic rock. I took my sedimentary rock, I applied some heat, and then a lot more pressure, and my rock now looks pretty different. I still have all those pieces. I can tell that this came from my two igneous rocks, but the rock looks very different from the sedimentary rock we created just a little while ago. Next, let's go to the final kind of rock, and let's get back to igneous rock. Now, I told you before, igneous rock is made when magma or lava, molten rock that I can find either deep inside the Earth or coming out of a volcanic eruption, cools down. So before I can make an igneous rock, I need to have magma or lava, molten rock. So I'm going to put my metamorphic rock back in the heat. And just to make sure it's hot enough, I'm going to add a little bit more hot water. Now this time, I'm going to let my rock get all the way melted. So I'm going to leave it in there for a good 15 to 20 seconds. Now let's see what happened now that I've let the sediments and the rocks completely melt inside the Earth. As you can see, my rock isn't just melty, it's completely melted. Now, as it's exposed to the Earth's air, it's going to cool down. This rock, this molten rock, is losing thermal energy to the area around the rock. Just like lava coming down off a volcano will cool as it loses thermal energy to the air. Eventually that hot lava flow will lose enough thermal energy that it will start to solidify. So as it cools down, if I wait for just a few seconds, you'll start to see that I've made something that looks completely different. It now looks like all of my former two igneous rocks, all of those green and orange sediments we started with, they've completely blended together. And I'm starting to see, as they're cooling, all of this igneous rock being created. One more time, let's talk about what we just did. We took two igneous crayons. We used weathering and erosion to create lots of little pieces of rock, those sediments, and then deposited them in the middle. We added pressure to compact those sediments and made a sedimentary rock. We added heat and pressure to create a metamorphic rock, and now after letting our rock completely melt and solidify, now I've got an igneous rock again. All of this happens over millions of years, again and again and again, and the rock cycle just keeps going. Ladies and gentlemen, the rock cycle.